in the lab. From part 1, you're shooting it horizontally. It's very similar to the problem we did on Monday. You shoot the ball horizontally, so you calculate how long it would take to fall, because you've measured that height. Once you have that time, you then can figure out how far out it goes. It's very similar to what we did here, definitely similar to what we did on Monday. The second part, once you have the initial velocity, well, you have the speed and the angle, thus the velocity, you can go through a problem just like this. So this will be the answer to what you got from part A. The angle is whatever you set it to, and then you go through step by step, and you come out with a prediction about how far it should have gone, and then you'll compare that to how far it actually did go. Questions to hear? I'm assuming that underneath all of your masks, you're smiling, just because it's picked you up so much. So, it worked. Now, in terms of, let's just think ahead to a test. All the projectile motion problems, from my point of view, are pretty much the same. The only difference is, what do I give you? So, I could have given you the horizontal displacement and then asked you how high the cliff was. So in essence, I give you this piece of information and then ask you what this is. I can also give these bits of information and then not give you the angle. Or not give you the angle, but don't give you the speed. And so there is so it's just a variations of what do I give you, what do I not. I guess and occasionally I'll throw in, hey, let's put it on Mars, let's put it on Venus. And so this number here would change. Just watch out for that. What is that?
So what we just did is for is that only for like the 50 meters per second, like that little space? If that makes sense.
Sorry, I mean, this is 50 because I gave that the problem, but I'm not sure that's what you're asking.
Well, I'm asking, like, is the calculations that we did for I-hat and J-hat, does that apply to like that entire picture, or is it just like the part that it says the 30 degrees and the 50?
Oh, the I-hat and J-hat is true for the entire problem. Time is the one thing that's going to be the same for both. Time is the only thing that's the same for horizontal and vertical.
So that time is over like the entire thing?
That time, that is the time it takes for the object from launching to hitting the ground.
Okay.
I guess from a pedantic point of view, this one right here is the vertical, so that's how long it takes for the thing to go up and then down, and the horizontal is how far the thing was in the air going this way. They just happen to be doing them at the same time. Oh, I could also ask for what's the final velocity. That's 5-minute warning. Oh, let's do that, considering there's only 5 minutes left. Final velocity.
Quick, before you get into that, this graph, you're saying that's a time?
Yeah, if this were position versus time.
Position and time, okay. And it's always going to be a parabola.
Projectile motion problems, unless you throw air resistance into it, which we're not.
Okay.
You're welcome.
Thank you.
Okay. All right, so final velocity. Well, I know what the horizontal component is, so this is just a matter of what is the vertical component. Our one blank left. We have all this information already written down. So which cake formula do we use to find VF?
We use the VF squared.
Okay, so VF squared
Is equal to the initial squared.
All right, so using this one, recognize that this is a speed here. This is going to tell us the speed. We do need to think at the very end of, that's the speed, but what is the velocity? Because down was made positive, it'll end up being the same number, but if we made up positive, then we'd have to think through and put in the negative sign. So this is equal to, now you've got actually some options here. Traditionally, we're going to plug in the J stuff. We just plug in verticals, because vertical is what's the piece that we don't know. And so this becomes 25 squared plus 2 times 9.8, technically negative 25 squared, plus 2 times 9.8 times, I keep saying technically it's a speed, times 20. So VF is
625. Wait, yeah, right?
VF squared?
Is it-
Oh, yeah, that's 625.
Yeah. Plus whatever that is. 1,117. No, sorry. 1,017. So, yeah.
I assume that's VF squared,
That is squared, yeah.
so VF
31.89.
0.89. So that is my vertical speed right before it hits the ground. Because again, once it hits the ground, my acceleration changes. We can't be using the cake formulas. So my final velocity is 43.3 meters per second I hat plus, because he said down was positive, 31.89 meters per second J hat. That's my final velocity. If I was feeling like it on, then I could, at what angle does it hit the ground? In essence, asking you to convert that to polar. We've done that before. Not particularly important at the moment. So one of the things that we're going to do on Monday is I'm going to do the 2 other types of problems here. 2 other, it makes it sound like there's only 3 types, but I'm going to do it where we have some different variables. And I am going to do what I consider the hardest of the projectile motion problems, where you need to find the angle. And essentially, there's 2 answers to that, and you need to be, it can get messy. You actually end up with 4 different angles, of which 2 of them are actually viable. But that brings in everyone's select tree. For those who, just something to anticipate. And I think on that note, have a wonderful and safe weekend.